Now in this one, we're looking at deep sea divers, and we first of all want to look at the first differences here to determine whether this is a linear or nonlinear relationship, and then we're going to check by graphing. So first thing is we have to figure out the first difference between -4 and -2. And I'll show the calculation first of all. Remember, you subtract the second value from the first value from the second, so it's -4 minus -2, and remember that becomes plus +2. So for the first difference, it's negative because -4 plus 2 is -2. So this is -2. And if you think about it, you're going from -2 down to -4. So that's a decrease of 2, or first difference of -2. And if we go from -4 to -6, that's a decrease of 2 again. So the first difference is -2. If we go from -6 to -8, that's the first difference of -2. And as we go from -8 to -10, that's another decrease of 2. So first difference is -2. Now, we'll make a prediction because first differences are the same, that it's going to be linear. And we're going to check our answer here. So up top here, and we're going to have time in minutes on the horizontal axis. And remember, it had the axis drawn here. And so this is going to be 0. And we've got to go from 0 to -10. So we're going to go down -2, -4, because this is depth in meters. And -6, -8, and -10. And we've got to go from 0 minutes up to 4 minutes. So we'll go every other one. So 1, 2, 3, 4. And make sure you spread out the graph as much as possible. If you scrunch it in, it's hard to read. So at 0 minutes, at a depth, and I'll change the color here so it's a little bit easier to see. At 0 minutes, you're at depth of -2. At 1 minute, at a depth of -4. At 2 minutes, it's a depth of -6. 3 minutes is a depth of -8. And 4 minutes is a depth of -10. And so these points all lie essentially on a straight line. And in fact, I'll draw it this way. So there's our linear relationship. And it is, as we predicted, a line. So going on to the next example with the hot air balloons, you're asked to find the first difference here. So we're going from 0 up to 2. So that's a first difference of +2. Then we're going from 2 to 6, and that's the first difference of +4. Then from 6 to 12 is +6, and 12 to 20 is +8, first difference. And so we're going to put time in seconds here because height depends on the time. And so the height will go on the vertical axis, and that's in meters. And our title can be hot air balloon. And we're going to go from 0 up to 20. So we can go up by 2s. Oops, sorry, that's going to be 8. So 2, 4, 6, 8, and then 10, 12, 16, and 20. And time, we've got to go from 0 up to 4. So we're going to go and at 0 seconds, you're at a height of 0. At 1 second, you're at a height of 2. 2 seconds is a height of 6. 3 is at a height of 12. And 4 is at a height of 20. And you can see that actually what we should have predicted here is, since first differences are changing, this relationship is nonlinear, and you can see this from how the points lie. Okay, that starts off a slow decrease and then constantly increases in speed, in rate of ascent, as how quickly the balloon rises. All right, so what we can do here is calculate the slope between two points. And so what we can take is the first point and the last point. And we go from zero, when we do our rise and run, so our slope is equal to rise over run. And our rise here, we're going from -2 to -10, so that's a rise of -8. Our run, we're going from 0 over to 4, so that's a run of 4. So it is equal to -8 over 4, which is -2. And if you recall, that's the same as our first difference. Our y-intercept here is -2 as well. And so our equation then is y equals -2x minus 2.